Test, 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 test. Okay. Hey guys, welcome back to another video, and today I'm gonna be showing you a new update that I just did. Um, Pardon me. Okay. So basically, what I've done is I've added. I think I had may have had sodium in the last update. However, it was not like anything. Like it had nothing to do, right? So here's what I've done. Um, this is just like a simpler, not simple, it's actually a very cool setup. We're going to use this setup for a second, just to demonstrate. So we have sodium, right? Also, new update, basically, if you want, because I've added in explosions, and the thing about explosions is that if they touch, like, boom, they'll explode the thing that they touch, like that. So if you don't want something that explodes, and sodium does explode, if you don't want, or sorry, hydrogen explodes. Sodium doesn't. If you want something that doesn't explode, use an E-wall. E-walls don't explode, and the reason why they're special is because you can kind of shock them. So this will actually probably be added later for my electrolysis update. Anyways, look, so like they don't explode. Boom, no explosion, or they don't get destroyed in an explosion. That's what's important, right? So just to demonstrate what I've done with the sodium, um, this is going to be a reaction that doesn't like have any special effects to it. I just need to show you the sodium. So if you combine sodium with water, which is in compounds, you're gonna get okay. Oh, oh, okay. Hold on. That's a very special thing. Let's do it in open air so that nothing really happens, or at least maybe like not much. So look, here's what's happening. The sodium and the water are reacting because the sodium is essentially, I want to say, I don't exactly remember what's happening. Apologies. But I know that the sodium is doing something with the water, and what ends up happening, it's most likely just taking the oxygen for itself, or something like that, so it's turning into sodium oxide. That doesn't sound right. But it does form a sodium, yeah, because it's turning into sodium hydroxide, which is, NaOH. Numbers. NaOH, sodium hydroxide solution. That is because it is in water, right? It's a solution because it's not pure. It's just in the water, so it's a solution, right? Something like that, I hope. But basically, it's reacting with the water, and it's producing so much heat that it melts itself. Now, sodium is not that high of a melting point. It's only, I believe, around 97 degrees Celsius. So, and water is 100 degrees Celsius. So what will end up happening is that the sodium will go up to 100 degrees Celsius and end up also burning the water and turning it into steam, but it's also producing hydrogen gas. Now, why that's important is because molten sodium will actually in this thing, what will actually happen is produce little fire particles, and those little fire particles will actually ignite the hydrogen. Now, the specific setup I want to show you here. Let me show you an actual demonstration of video for it first. I found this guy, right? He does super cool stuff with the reactions, and he actually shows us this sodium reaction where, look, the sodium's molten. That's why it's all like uh moving around and stuff. Let me improve the quality on this so it looks a bit better in the video. And let me unmute him. A Coulomb explosion. Boom. You see that? You see that? That's because the hydrogen is, or I really hope I'm correct, and if I'm not, I'm just going to sound really not smart here. But that's because the hydrogen is building up in the little canister. That's why it's tilted sideways. Is hydro... Nope. I did not mean... Sorry. Is hydrogen heavier or lighter than air? Oh, wait. Does that mean it goes... Oh, well, okay. Wait, does that mean it goes up or down in air? It would go up. Oof. Okay, so I'm super wrong. Wait, he just explained it.
basically the word Coulomb comes from electrostatics. It's because of positive charges repelling. And so when this thing decides to go, it goes very, very fast and very, very forcefully. Here's a
Mm.
couple of
Okay.
deployed shots of us
Interesting.
dropping sodium into
Look,
the
look, look,
beaker.
look, look.
Now, luckily, I thought to put plexiglass right between the camera lens and the actual beaker below, because as the explosion happens, you can
It'll
see
look
that
better
it
in a
goes
second.
very, very fast. It actually shot probably 3 or 4 feet in the air and absolutely would have destroyed the lens, or at least got water all over the lens and probably some of that molten sodium as well. So when it happened the first time, it was mostly water that shot up, but on the second explosion, you could just tell it was a lot more of the molten sodium itself because it really damaged the plexiglass and turned it black and scarred it and charred it in a few places.
Okay, he's gonna explain it, but I'm gonna see if I can explain it before he does. Basically, what's happening here is that he dropped the sodium. It was just like a sodium metal, so it basically just looked like this when he dropped it in, right? It was just a sodium metal, and he dropped it in, and the sodium in the water, that reaction started heating up so much that it turned the sodium into molten sodium. And the reason why it doesn't just spread out or something is, for one, is sodium denser than water?
Good
I'm
shot that
okay. I
actually
didn't mean to do that. Is sodium denser than water? Yes, waiter. No. That means it's gonna float. Yes. Okay, so that's also one reason that it just is that it does whatever this. Sorry, that's one of the reasons why it just kind of does this. But the second reason is because underneath it is a like the hydrogen that's forming. That's because the sodium. That's the part of the sodium that's in the contact with water, or at least mostly. And there, that's where the hydrogen is forming. That's why it kind of forms this little ball and just kind of floats on top.
things get going, it forms a
Or no, no,
ball.
no. It forms a ball because it's connect. It's like stuck to itself. The reason why it's floating is because of the hydrogen.
It's completely molten due to the heat, and
Yeah,
it's just kind of scooting on a
scooting,
layer of hydrogen. Also,
scooting.
sodium is less dense than water.
Yes,
So it just does this until the Coulomb explosion happens. We'll talk exactly how that happens in a second. But when it
it's
goes,
kind of like
that particular
steam.
explosion, I remember, would have absolutely destroyed the camera because it turned the plexiglass completely black and pockmarked it with all kinds of craziness.
Boom, boom.
And you can see clearly those chunks of molten sodium
Whoa!
going straight up toward the beaker.
Wow.
So let's get a little closer to this explosion. Before the explosion actually takes place, you can actually see the molten sodium beginning to be thrown off very violently. This is very different than the way it looked just a second ago. And then it reaches some critical height
Wow.
and the explosion happens and it's over in an instant. Now, I promise you, this is worth the wait to the end. The sodium goes into the beaker, goes underwater. You can see the hydrogen gas being formed immediately upon plunging under the water. This large bubble immediately forms and pops. And then here I'll speed up the footage just to kind of let you cook along. It turns into a molten ball and scoots around. Here is a flash of ignition that happens way before the main explosion. Here I'll speed up the footage a little bit. We'll get past that point, and then you can see that it's starting to throw off little chunks of sodium and generally getting more
Okay.
and more violent.
I'll have to watch this video later because it's kind of interesting. But yeah, that's essentially kind of what's happening. I've set up a demonstration about this. Okay, so we're gonna see two things here. Kind of the one experiment that he did. However, I get way better results making something like this because the sodium and the hydrogen, even if like put in different amounts, it'll like the shape of the whole entire thing itself will actually facilitate the explosion reaction. We want to see a lot better. So let's get started. Look, so in here we actually have to put in a bunch of sodium for it to react and explode, hopefully. Please, don't embarrass me, please. A little bit more, maybe, please. See, like, as you can see, it's still pretty difficult to get the correct amount in. And for it to explode, you kind of have to just eyeball it, I guess. Uh, interesting. Let me oh my gosh, I just look dumb here. Okay, let's try this again. Water, elements, sodium. Hopefully this does it. Come on. See, it's very difficult to do it in this beaker because there's barely. I mean, it's just not working. Right? Let's just dump in a whole bunch of sodium. Maybe that'll help. because maybe one of these molten sodiums will react with. There we go. Ah, there we go. Look at that. That's what we're hoping for. Now it's starting to melt the water. Melt. Sorry, not melt. It's starting to heat up the water, turn it to gas. We don't want that right now. So here's how this one works. Really simple. Boom. You see that? Almost instantly, we got a big fire explosion. That's what I like about this one. Is that you can literally just take sodium and put it in, and it'll just boom. Embarrassing. Hold on. Boom. You see that? That's because let's go to the point of nucleation here. That's because whenever okay, look. So the best possible way to do it is just to cover the entire surface of sodium. And the reason why this works the best is because there's so many little grooves and divots here that the gas has to like can move into that it just kind of like stays here for a lot longer than just a straight tube up, and so that gives the molten sodium a bunch of more time to react with it, not really react with it, but set it on fire. And so it actually works a lot more of the times, and and the reason why I like it is because it has these little reserves that don't immediately heat up in the explosion. Like this is 232. This would almost immediately, uh, what do they call it when it turns into a gaseous form? Something I don't know. I forget. It's like 11 in the morning, or it's 11. It's 11 at night. But it won't. It won't heat up to where it turns into a gas because it has these power banks, heat banks that prevent it from doing so, as well as its own heat intake. Because water has a pretty good amount, so it'll actually provide more water for it to react with, which is cool. Now, I have another demonstration that I would like to show you that I also added. As you saw earlier, there was two different oils. Why is there two different oils? Well, there's a reason. Look, this oil is actually regular normal world oil, where if I were to set it on fire, obviously, the only top of the thing's burning. However, if I were to smother it somehow, like maybe let's just say with water. If I were to smother it with water, these bits of oil are no longer burning. Now, okay, this is a very bad example. You're never supposed to put oil in water because it would just like spread it. However, as you saw, it's literally in a little thing. It's not going to spread anywhere. Let's do a different example. If I were to cover it with sodium, sodium is a little bit of a better thing. If I were to cover this with sodium, this is normal oil. Let's just say I threw a whole bunch of sodium on there. Boom. These things immediately stop burning. Now, how do I know? It's because, look, if I were to take some oil, boom, and I were to give it heat, fire, boom, just drop it. As you can see, if I hover over one of the little oils, it says burning. That means it's burning. However, earlier, even though we saw that these were burning, now they're no longer burning. That took forever to code in, by the way, because it's not easy getting. It's not easy. All right, so now what is this special oil? Well, the special oil is actually just the oil that I used previously, where even if you smothered it, it would still burn, as well as it also burns the oil below it, which is why you saw those like super cool flashover kind of things. Look, if I were to heat this, what is up? Molten sodium. Okay, I kind of did this wrong anyways. What I want to do is I want to take special oil, take a whole bunch of it, and then ignite only a single bit of it. Now watch. As you can see, you saw how there was barely any coming out. It would actually be better to show it in a clear one without this little barrier right here. But you'll see it pretty clear as day, where if I were to take that special oil and just kind of like go like that, and then only ignite maybe a little bit of it, as you can see, look, this is what I'm talking about. You can only see fire coming out just in sparks, right? Spark, spark, spark. But then all of a sudden, wow, wow. And there's a whole bunch of fire just starting to come out. That's because the burning is beginning to reach all the way to the bottom where it hasn't, and all that fire from the bottom is beginning to reach from the top. Now, the reason why this is important is because this specific oil burn hotter than the other oil because it's burning the ones it's burning all the oil. However, it burns for less time. Now, not exactly, because both oils burn for 5 minutes in real life in this game. So 5 minutes in the game is like it'll burn for 5 minutes, right? And so what ends up happening is what ends up happening is that by the time 5 minutes is up, all of this will be gone. However, if I were to burn the other oil, only that top layer would burn off, and then the rest of it would keep burning, because it'll one of these, like, once it like drains like this oil will come down here and burn this oil, and it'll just continue the process. Now, do I have 5 minutes here to show you? Probably not, right? But as you can see, and the reason why this oil burns hotter is not only because this bottom oil is producing a lot more heat than regular oil would, because this bottom oil is also burning, but it also produces a lot more fire, and fire is a lot hotter than smoke. So if I were to put something, look, here's honestly the best way to demonstrate this, right? We take two different chambers and we put, maybe like some sort of barrier, flat barrier without any divots, right? Oh my goodness. Well, let's just put the same amount of oil in each. Um, Here, boom, this much oil. It's not the same amount, but it's kind of like, who cares, right? It's about the same. That's all that's important. Now, maybe just about remove that much, like that. Now, let's heat both of them. So this is the oil that only burns the top layer. This is the oil that burns all of it. As you can see, not burning. Only the top layer is burning. Now, if we check, look, 110, 35. Not hot in the slightest. The best way to show this, really, really quickly, the best way to show this is by putting sodium in them. And the reason why is because sodium, very hot. Okay. We're gonna reset the thing. Is to put sodium, because sodium has a very low melting point, so whichever one melts first is the faster one at melting. So we'll actually just create a chamber, and we'll make sure kind of just like make the chambers just even amounts. It's about even, very close to it, even. Just maybe just like a little bit less. There we go. Okay. And you're gonna put sodium on top, right? So sodium, and then you're gonna take each oil. Now, is there a more scientific way to do this? Yeah. Um, am I gonna do it? Maybe later. Not now. Okay. Now set both of them on fire at the same time. Boom. Oh. Uh. Okay. Well, that was a bust. Let's try something else. What burns at a high temperature? Nothing. In fact, nothing actually burns at a higher temperature. I have in my code. So now, if I'm going to do this really fast, is the time to show you how I'm going to do this. Ready? We're going to speed run this too. Watch. Okay, look, so you come here, go to my mods, go to mod, open up the chem. We're probably going to do it in Visual Studio Code. That's fine. Yes, open it. It was made by me. Stop this so that we're not running. It's opened up on the other monitor. Alright, so now what we're going to do is we're going to say iron, right? The game automatically has states for iron, so that's really simple. All we have to do is look up the melting point for iron. Melting point of iron. 1538. Alright. So all you have to do is come down here. This is attached to this one. Perfect. So you just gotta say, I think it's temp high. What was it? 1538. 1738. And then, we're good, right? We don't actually need to do anything else beyond that. And it's not going to mess with our reactions either. And this should be iron, which it is. Now you come over here, reload the game. Boom. Now, if we were to take iron, heat it up, very hot, Give it a second. 1538 is what we're shooting for to see if this thing. Oh, look, and it's turning colors too. That's also a special feature. Look at this. Hold on. Oh, some of it's. Boop. There we go. Look at that. And that iron's still somehow. Look, so now it's molten iron. And as you can see, it does burn. Right? That's the whole other thing with molten sodium. That burns too. Alright. So, we'll just do this. This is actually a little bit better. If we were to just take E-wall and separate the two chambers. Boom. Now we have two mostly accurately similar chambers. I don't have a thing, so what I mean, there's no good way to separate the two chambers for their heat purposes, so I'll probably just maybe use just my own thing. So what we can do is just quickly take some E-wall, make a chamber, make a second chamber, separate the two chambers like that, and that's a close to the same thing, if not the same thing. Sorry if this is taking forever. Take some special oil, put it in some other, delete some of it, take some oil. So I leaked. I don't want to leak oil. And then just delete some. Perfect. Now we set both on fire, and we put the element iron on top of each one. I don't know if I use the same amount here. Let's go E-wall. It'll show it's about this much. So, boom, boom, like that. Boom, boom. I'm gonna come over here. I'm gonna put the iron so that it's not touching anything, and it's also the same size as the other iron right here. Boom. Now, as you can see, this is the special oil, the one that burns all of it. And as you'll see in a second, it's gonna start flashing over. So you'll see, yeah, there it is, a lot more fire up here. As you can see, this is heating up way faster than this is because only the top layer is burning. You gotta remember that only the top layer is burning. Just to delete that. Look at this. So this will. Now, is this gonna take a while? Yeah. I don't know how hot it does get, though. So, and we also want more fire in the mix. So I'm gonna add just this very tiny chamber. Boom. And that'll create like 10 times more fire for it to produce and heat up the thing with. Now, is it gonna take forever? Looks like it. Yes. I wonder, does iron, okay, while we're waiting, does iron explode or not? Like, will it melt in an explosion? Oh, it will be destroyed in an explosion. How hot are these explosions? Only 500 degrees Celsius. Not even hot, well, yeah, all around the board. Except some are like 570, but that's near the nucleation point. And that is barely hot enough to facilitate the iron reaction. So, no bueno. Not good enough. We're still waiting on it to heat up. While we do so, why don't we just continue looking at reactions and whatnot? What else should I don't know what my next thing should be. I don't even know if I should improve on certain things or not. Or if I'm still, like in the phase. Or, I don't know. I don't know what to do next. Look, as you can see, this is obviously not going to heat up. It's actually not heating up beyond like 58 degrees, but this definitely is. Because it's producing a lot more fire. As you can see, the iron is definitely getting hot. This iron's not getting hot in the slightest. This experiment is new. Not going to work. It's almost to the temperature where it's enough to facilitate a air iron reaction to form iron sinter. Almost. I say almost because it's not there yet. But we're getting there. So I'll probably just have the video time stamped so you can go to the part where it's done and see which one got there first, although I do think we can already tell. So while you're not watching this part, I'm gonna need an airhead because I feel like it. And because this is my video. So, this airhead's blue, but the package is green. Why is that? Whatever. It's good. It's good. Food. Food. Yum 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 yum. Oh. Oh. I'm gonna go on mute while I do this. I'll be back. You might be wondering why I did that. There's actually a very good reason. As you like, the more mass you have, like the more mass the object has, the more energy, I guess you could say, it takes to heat up. And that's actually what's probably slowing this other reaction down like pretty heavily. Is that there's so much for it to like touch and react with that it's just kind of like having to heat up such a big mass. As you can see, it's already like having a difference between having to react with such like a heavy mass. I don't even know what I'm saying. I think it's just very late for me. But yeah. And this is still like look, it's already increased 20 degrees just because I removed some material. Like the more material you're gonna have, the more energy it's gonna take to react or sorry, heat up. It's already at 150. Wow, this guy's almost at 1,000. Thank you. This its thing is almost at 1,200 now. It's gonna be a race against the clock to see if this even will turn it into molten iron because 5 minutes might be almost up. Um, and the iron's only at 918. We're still missing what is that like 600 degrees, and this isn't showing signs of heating up very fast. Like it's still heating up, and oh, oh my gosh! Wait, we gotta save this. I didn't expect it to be like that. That is so funny. That's actually hilarious, dude. It just like it just like combusted. Oh man, but we're gonna be starting from like a much lower temperature because this oil still has to heat up. Wow. Okay, so it doesn't. You might need just like a lot of oil. So here's my idea. You take iron and then you make a very thin E wall around the iron, and then you just dump in a whole bunch of special oil, and then you light that oil on fire. Boom. Now we're gonna try and see if this can burn it. Burn, burn, burn. Looks like that's burning, and then that's perfect. So now this is heating up very quickly. So I wonder if it'll turn into molten iron because now it's on direct contact, and there's like a lot less jibber jabber it has to deal with. Of course, the iron's just, I'm sorry, everything is just burning. Look, it's almost the color of the oil. Incinerate, oh, I don't even know if y'all saw me use incinerate, but incinerate's just nuts. Because look, if I were to do a whole bunch of E-wall and then do incinerate, watch how hot it gets within seconds. I'm gonna click it once for like a little bit. It added 10,000 degrees. It's very, very hot, right? That's usually why I don't use incinerate because it gets super hot. Now, this is already 1,000 and it hasn't been a minute. So we might genuinely be able to get to 1538 before the timer runs out, unlike earlier. Now, is this the most optimal method? Not exactly. You're gonna have to still wait your 5 minutes to get the iron out because you can't really put it out. You can't put this stuff out. And I've tried, right? I've really tried to put it out. Now, it looks like it is going to touch 1538. Ready? Boom. And it's molten iron. Amazing. Now, what do I mean by I've tried? Well, let's just put in a whole bunch of special oil. Now, here's what I really mean. You can see the real demonstration of what I mean by flashpoint. Look, do you see how it's just a whole bunch of little flashes? Flash, flash. Ooh, that is the flashpoint. That is the point where it just melts. Or it just does all that. Now, put water on it, you can't. The fire stops it. The fire will just create a whole bunch of steam. Okay? What about maybe like carbon monoxide? Nothing. Okay. What about rust? How about rust? Nothing. It doesn't even stick in there, it just falls. So it doesn't do anything. Okay. Maybe let's try sodium, right? Sodium melts. It doesn't mix. Most technically, you can get less fire because the molten sodium is just on. Like compared to the oil, you'll get less fire, right? But still, it'll be molten sodium. And even now, you can see how the molten sodium is a very slower flashpoint where it'll create more and more and more and more fire very slowly. Unlike what we saw earlier with the oil, special oil, where it did that little flash very, very fast. Look, flashpoint extremely quickly. What about the flashpoint of sodium? Do as much sodium as we did it before. Sodium. What's the flashpoint? Very slow. As you can see, it's very slowly ramping up. So, what about it, right? Now, here's also another thing you can do, which I thought was pretty nice because it's a physics engine thing. I didn't even make it do that. Well, technically I did because I coded in the densities. But look, oil does not mix with water. How nice is that? Well, I mean, what if I just set it on fire? Will it melt the water and then it mixes technically? Like, watch. Oh, is this oil special oil? This is just oil. It won't actually melt the water. Not if it's, unless it's in direct contact. So let's just put down some special oil. There's just a little dude over here who's just still burning. Oh, that'll ignite it. This will get very hot very quickly, yeah. Oh my goodness. Hey, look, it's water mixed with, you know, it's like, oh my gosh. Yeah, it almost immediately vaporizes it because it gets so hot. Now, it's less technically realistic because all the oil is burning at once, which is the problem with that one. All the oil burns at once. So you're basically it's just like gonna get very hot very quickly, which is why you saw the water do what it did. We can also demonstrate another thing. What if I put water on top? Where's water? Water's here. What if I put water on top? It'll actually slowly start to seep downwards, right? I don't know if that's correct. I hope it is. Look at it. It'll seep downwards because water is supposed to be on the bottom. And oil on top, right? Pretty nice. Well, anyways, that's pretty much it for the video. Let's just end it off on a bang. Let's melt the water. Very quick melt, by the way. Look at how fast that is. Almost like very, very fast. Alright, I will see you guys next time. Bye-bye.